Okay, so if we have a bucket, for example, there's multiple ways you can draw the bucket. So here's the bucket. What would we do if we want to draw this bucket? What's one way you would want to draw the bucket?
Circle.
Okay, which circle?
On the top.
Okay, we could draw the top circle right here.
And then.
So, and what plane are we talking about? Remember, let me draw the planes here.
A horizontal plane?
Well, we have the X, Y, and Z. Oh wait, I'm sorry. I think the X and Y can kind of change depending on like what company. So I think this is what we used last time. Okay.
Yeah.
The X, Y, and Z. So what plane do we draw that circle?
Is it on the XY?
It's on the XY, correct. You
Yeah.
see this plane right here. That's your XY. So if we were to look at this XY plane face on like this now, this being the X, this being the Y, you draw your circle, right?
Yeah.
Okay. And then?
And then take a circle and do
Do you remember the term?
extrude?
Extrude, yeah.
Yeah.
Now, before you can extrude, okay, so you're going to extrude. Okay, good. Before you can extrude something, there's something key to note. You have to have an enclosed shape.
That's true.
Okay, so if you have something that looks like this, you cannot extrude this. Yeah. Think of it as, well, I don't know. I just know MS Paint, like the old school thing. If you try to do the little fill bucket,
Oh yeah.
it like if you have an opening, it's gonna spill out and color the entire page. Okay.
Yeah.
Yes. Question.
Yeah, this is one of the things I was trying to figure out while watching it. Is extrude kind of like rendering?
No. Extrude is basically taking a shape and just giving it thickness.
Or stretching it.
So, for instance, yeah, we're just giving it thickness. So if you're to draw this thing, this on its surface is a hexagon.
Right.
And then you extrude it, you give it thickness. That's what extruding is. Now we're just giving it thickness. So for a bucket, it's not just a circle. It's not just a ring, right? A bucket has depth to it. So what William just said is we're going to extrude it. Okay? So if we extrude it, you're going to come out of the z-axis. You see that? Z is coming in and out of the page. So it would be like this. Okay, Z. Okay, so now we extruded it. Now it looks like a big cylinder. It's a cylinder block. Okay, we want a bucket though, right? A bucket is hollow on the inside. You could put things. So what would you do?
And put a circle on the bottom.
Okay, what plane is this?
Would it be the
Yeah.
X? No, Y. The YZ.
The YZ is going to be a plane that goes like this.
So it would be the same thing.
Yeah, it'll still be an XY,
Yeah.
right? It'll
Yeah,
still
yeah,
be
yeah.
like that. It's a transverse cut, okay? That would still be. So where I'm going to draw the circle is actually, you don't have to, think of the XYZ as like the corner of this desk. That is where 0, 0, 0 is. 0x, 0y, 0z. Like, so right now we have a circle, and then it was drawn on this corner of the desk, and then we extruded it. So we have a cylinder right now with the bottom of it. Here's our cylinder, basically. We have a cylinder with the circle center in that corner, and then you just gave it thickness. So now, if we want to hollow it out, naturally, let's say this was an actual cylinder, how would you hollow it out? You'll start scooping it from the top, right? So what we could do is, you don't always have to keep drawing on these three planes. XY is your top surface, and then we have YZ right here, and then YX is this surface. Okay, you can look at the corner of your own desk if you want to understand. You don't always have to draw from this surface. You can draw from a parallel plane. So this plane right here is parallel to what? XY, right? It's parallel to the top of the surface. So what I'm going to do is we're going to draw a circle on this surface right here.
And then bring that down.
Exactly. So that's a surface, right? Do we agree the top of this cylinder has a surface?
Mm-hmm.
You can draw a shape on any surface. Okay, so we just created a new surface, and we're going to draw on there. Then we're going to do an extrude cut. So extrude, they go by different names. It might just be cut. I forgot what the software calls it. But basically, instead of giving it thickness, you're removing material. So think of it as a drill bit now. It's just basically going in and cutting out material. Okay, so you're going to extrude cut, and I'm going to draw the dashes. In engineering terms, dashes means hidden. You cannot see it, but it exists. All right? I see your bottle, your tumbler on the table. We know it's hollow on the inside. We know the straw goes through.
Yeah.
So if you were to draw that, you would draw straw. Oh, the part that you do see will be solid. You see like this will be solid, but then the part we don't see is going to be dotted, okay? So we know it extends inside. So anytime you see dotted, that means it's hidden lines, okay? For example, you guys see this object? You see how there's edges on it?
Mm-hmm.
If you were to look at this thing like this, how would you draw it? Or there's a hidden line. I guess that's what I'm trying to bring up. This is hidden back there, right? So you don't see it, but it exists. So you would depict it with a dashed line. Okay, so that's another example. It doesn't always have to be an internal surface. It's just hidden from your view. Okay, so anyways, I just want to explain why we use dashed lines here. So you see, we drew the second circle, the one that the red arrow is pointing to, and now you cut into the material. And now you have your cup. Do you imagine it?
Yes, sir.
You got it?
Yeah.
Okay, so we started with a solid, then we drew a circle on it, and then we cut in up to a certain depth. Oops. Up to like this depth, we cut. You don't want to go all the way through. If you go all the way through, now it just becomes a tube. Yeah, it becomes a tube. That's basically what happens if you go all the way through. If you stop short, then you actually have like a cup. All right. Cool. The other thing, yes, you have a question?
I'll catch up on the
Yes.
X, Y, and Z plane is
Yes.
a little.
Oh, okay, okay.
Now, but I'll catch up.
X, Y, and Z, just imagine the corner of your desk. If you were to tell someone, like in like Battleship or chess, I want to move forward this amount, you would tell them, go right, whatever amount of inches, and then go forward. But we're going to use the terms X, Y, and Z. Okay,
But are they always on an angle like that?
So the reason I drew it on an angle is, it's actually not on an angle, it's just perspective. It's like if you look at this.
I can see the corner of the
Yeah.
table there.
Is it always going to be that particular angle, you say?
Yeah.
Not always. The Z is basically agreed upon to always be up and down,
Yeah.
but depending on your software, sometimes the X and Y could be flipped.
Can you remind me what software we're using?
We are using Autodesk Fusion.
Thank you.
So
Yeah, but the Z is universally accepted to be the up and down direction. Yeah.
maybe I'm not good at a lot of this, but I always thought, I think of a graph, like if you're plotting something
Mhm.
on a column, X.
X, Y.
Y would be your vertical, X would
Yes.
be your lateral, but in this class with CAD, Z is your up and down.
Yeah, so when they say XY axis, you heard of that?
Yes.
Yeah, we're going to plot a graph on XY axis. They're talking a 2D. So basically, they're looking down. This
We're
is
looking
X,
at 3.
and this is Y. That still applies. So basically, I took this piece of paper that's the XY and I flattened it. And that's where you see the XY. So that is still true. That still holds true. But now, instead of just looking flat, we're going to have 3D objects. So we still have X, we still have Y, but now we have Z.
I understand.
Okay.
I'm good.
Yeah.
Thank you.
Okay, so we're going to keep referencing X, Y, Z. I'm going to tell you, you want to start on this surface, the X. So there's a surface is going to be defined by two axes. A plane, let's just say that. A plane is defined by two axes. So we have, what is this plane? Like the actual projector screen. What is this plane? The ZX. Do you see that? The ZX is this flat vertical plane that we have here. Okay? And then what about the surface, if I was to hold up this paper, if I was to hold up this paper, what is this plane? The YZ. You see that? I can't draw. Ready? Okay. I can't draw 3D on a flat screen, so I'm just trying to depict to you. This is what I'm trying to show you, is that we have the 3D. Yeah, we call it the right hand rule. Okay, you can hold it like this. Okay, so this is your thumb is the Z axis, and then what's the other ones? Okay, well then this would be like the Y and then the X, except the X is backwards. The right hand rule is actually later if you do like torque and stuff like that. They always reference like things about the X axis, and they use your right hand instead of your left, because that way your fingers are pointing in the right ways. but you can kind of see what I mean is you have a portable corner in your hand. You can see the Z and then the X and then the Y. Okay, so I just want to show you like this is what I mean by the axes. I can't actually draw 3D poking out of the screen, so I had to draw it flat. Okay, so the software is going to depend. I mean, it's going to depend on the software, but universally we basically agree upon Z as going up. So you have to check like what each software uses. We're going to use this as a reference point though. Okay. All right. What's another way we could have drawn this cup? Do you remember the other method I showed last time? Hmm? Oh, that's what we did just now. We made a shape, we made a cylinder, we extruded it up, and then we cut into it. But there's another way you can also make.
I mean, can you not draw a square for the instead of extruding it?
Huh?
Instead, can you not make a square for the base?
I mean, yeah, you can. That would just be a box then, right? So if he did a square, hello. If he did a square, that would just be a box. Can you see that?
No, I mean, like draw a circle up for the top, and then draw a box, and can you not connect it? To the circle?
You can. That's called lofting. Okay, so that's gonna be maybe later on we can talk about that. So he's talking like you have a thing like this. It's a square base, but then it's like a circle top. But to interpolate the edges, that's lofting. So don't worry about that just now. It is possible though. I can show you in the next story.
Doing that method too. That's why.
No, the other method I was talking about is called revolve.
Oh yeah.
Do you remember? What does it sound like when you revolve something? You're rotating something. Yeah. So do you remember how we made it last time? Can you describe how we can also draw the same shape that you see here with revolve method? Uh-huh.
I mean, I already.
What's that?
I have like an example.
Oh, he drew it right there. Okay. I'm going to draw it on the screen. Basically, what you can do is when you have a circular part, there's an axis of rotation. Do you see that? Like look at this thing. If I was to put an axle right in between this thing can rotate like this, right? Okay, so that's an axis of rotation. And no matter how I rotate this thing, it still looks the same all the way around, right? So we use that to our advantage. What we do is we can draw a shape like this, okay? Then I'm going to draw this longer dash line. So there's differences in dash lines. When you have longer dash line, that means it's an axis or a center line. When you have short dashes like what I showed there, that means it's hidden line, okay? So that's just to make a distinction. So when I draw this thing, an L, and then I put it on this pole, and I spin the L around the pole. What is it? What kind of shape does it? Think of it like you've seen a fan, right? You see a fan blade. Okay, well we have the fan on our desks. You have an individual fan blade, but then you turn on the fan, and now it becomes a circle, basically. Okay, so when you take this L and you rotate it about, the L's like this. The L's like this, and now I'm gonna spin it around this axis. What shape does it carve out? No, because think about it. You're rotating around something. It's gonna,
You just move in,
yeah,
it's
it's going to become, it's gonna sweep out a circle, right?
Yes.
When you rotate something, it sweeps out a circle. You're gonna end up making something that looks like that, just like what we had before. That's another way you can make something. The reason you might, sometimes you want to do one method over the other, okay? Can you think of a reason why we might want to do the revolve method over the extrusion method? A cone, okay? For example,
Oh, yeah.
because the extrusion, remember, it follows a straight line. Although that's not true. You can have it follow the curve, but for our purposes for now, we're having it follow a straight line. How would you, if you were to draw a cone, this is a cone. Oops. Here, I'm going to draw it like this with the dotted behind because we know it's a full circle. If you were to draw a cone with the extrude method, you could draw a circle on the bottom, but then the other end is literally a point. And then if you try to extrude the normal way that we showed earlier, you would end up like cutting the whole thing, right? That wouldn't work. So can you give me the profile that we need to revolve a cone? Do you know the profile that we need?
We basically do a triangle.
And do we want a hollow or a solid cone? Let's do a hollow cone, okay? Let's do a hollow cone. So it's going to look like this. Again, dotted lines to show you that's internal. We have a hollow cone, okay? So basically, this is your ice cream cone. It's hollow, without the ice cream in it. All right. So the outline, if we're going to revolve it, is going to look like what? It's okay. First, you have to find the axis of rotation. Where's the axis of rotation? It's from the tip to the center of the bottom circle. Let me draw the longer dashed lines. Okay, now you only need to draw half of it. So previously, you guys gave this recommendation. This will technically work. You just revolve it 180 instead of 360, because by the time the U makes a 180, it's already completed the turn. So yeah, you could technically do this. Say I drew it like the 1L, and then that way it has to swing the entire 360. Yeah. So the cone, if you were to draw this, this will be your profile. It will look like this. Oops. Let me do that again. Do you see that? Oh wait, that's wrong. Where did I make a mistake? Does anyone know? That's wrong. Yeah. Yeah, this is actually like an enclosed triangle. Like I closed it off. We wanna open it up actually. It'll look like this. If you were to revolve it, it would end up like a shape like this. Just like what we have over there. It's like a teepee tent. All right. We'll practice more in the computer lab. How about that? I just want to go over this because later we need to take these concepts and we need to apply them in how we draw these things. Okay, let's start simple. This is our object. Does everyone see the object? Okay. How would you draw this? What approach would you use to draw this thing?
The one we used the first way, the extruding way.
Extrude. Okay, what do you extrude?
Yeah.
Hexagon.
The hexagon? Okay, and on what plane do we want to extrude this hexagon on?
X,
Huh?
XY.
Yeah, so there's actually, it doesn't technically matter. Like I can lay the thing here, or I can lay the thing here. I usually draw it in terms of how is this thing going to be oriented in use. Okay, you can always reorient it later when you assemble things together, like a bolt. A bolt isn't always standing up straight. A bolt is sometimes this or whatever. But I try to orient it in the way that it's going to be used. Just like this can is typically going to be resting like this, not like sideways. You can draw it sideways. It's still going to be valid. But I like to put it this way. That's just for my own sanity. Yes?
Just a quick, could you do that in front of the camera since you're recording?
Oh.
Because it's like, at home I was like going, what is he talking about?
Oh, yeah, I'm sorry. Yes, I go a little off screen. Yeah, so right here, this is the device that we are trying to draw. Okay? Do you guys see it's like a hexagon block, all right? So the suggestion was what again?
XY,
XY, and what do we draw on the XY?
hexagon?
A hexagon, okay. Right now, I'm not going to worry about dimensions. In reality, we have to give dimensions, because otherwise, how big is the hexagon, right? But for now, let's just draw a hexagon. And there you go. All right, more or less. Okay, on the actual computer program, you can do a better job. Then what do we do with it?
And then extrude?
Okay, we extrude. So I'm going to go back here. I'm going to draw the hexagon flattened on our XY. And then we extrude up like this, right? We give it thickness, so then it ends up being like...
Does it matter if you extrude up or down?
No, technically, again, it doesn't matter. But imagine our XYZ is the surface of a table. You would want to extrude up away from the table, right? Instead of into the table. Yeah. Again, solid object is solid object no matter your orientation. But it makes most sense to extrude out of the table. So, okay. Do you guys see that? The more complicated approach would have been create a rectangle. You see the rectangle? This is technically a face.
Yeah.
Yeah. You wouldn't be able to revolve. Otherwise, it would be like a cylinder. But rather, you would have a rectangle, and then you would like have to angle the next rectangle every... What's 360 divided by 6? 60 degrees. You would have to angle it every 60 degrees, and then you put an end cap on both of them. That's way more complicated. You see that? That's why it matters to understand the different technique, because you could have drawn it that other complicated way, or you could have drawn it in literally 2 steps like what we did here. Okay, so we started simple. Let's do a different device. This one actually has 2 different ways you can approach it. I'm going to show it on the screen, and then I'll pass it around. Okay, look at the side profile. What do you see? Sorry. It's a trapezoid. Yeah, you see that? Okay, so we have a trapezoid, and we have just, other than that, it's just flat surfaces. This is a tripod plate. Since there's only a couple of us, you can just pass it around and look at it. I will draw it here also, just to show everyone. I'm going to orient it this way. Again, multiple ways to orient it, but I'm going to just orient it like so. This is our device. It's a trapezoid. That's actually a tripod plate that you put on the bottom of your camera, and then you screw that into your bottom of the camera, and then you put that on your tripod. Yeah, so anyways, I drew the shape already for you.
Does the software have a trapezoid?
You can create your own free-form shapes. Basically, the software has a line tool, and you can, just like my pencil goes here, and then it goes here, and then here, you can draw like whatever shape you want. Like, there you go. There's my organic shape. It doesn't necessarily have a trapezoid tool, but it has the ability for you to draw whatever shape you want. And then if you don't draw it perfectly like what I did, this is later where you come in and you constrain it. You have to add dimensions to it to get it to like be perfect. Because we see this side and this side is the same.
Yeah.
All right, we want them to be the same, so you're going to tell it in the program, I want this face and this face to be the same. And then it's going to make it the same in the program. All right. Okay, so how would we approach drawing this thing? How would you approach drawing this thing? At least in the orientation that I have it here. So I basically put it flat on the table like so, which is our XY plane, okay? Multiple ways to approach this. But there's probably one most straightforward way to approach this.
Would you draw a trapezoid and then just extrude it?
Exactly. Okay. Where do we draw the trapezoid?
XY?
No.
No.
Yes,
Yeah,
exactly.
yeah.
Good job. Yep. See, you have to take note. You have to take note of what we are doing. Okay, so now we are drawing our trapezoid like this in the ZX plane. Do you see that?
Yeah.
The Z is the vertical, and then the X. That defines a plane that is vertical like this. We drew a trapezoid like this. Can you envision it now?
Yeah.
Yeah, this vertical plane. And then what do we do?
Extrude.
Yeah, now we're going to give it thickness. Basically, if I was to draw this back here, now we can extrude it. And now it becomes this thing. Okay. What's another way you could have drawn this thing that's not as elegant? Yeah. There's multiple ways to skin the cat here. Anyone else can think of a way? Encourage alternative versions, even if you don't use it.
I mean, technically, can you draw a square?
You can draw a square. Okay. What face were you referring to with the square?
The X on the top. Draw an
This
X
one?
line. Yeah.
Okay, yeah. Okay, so let's say you drew the XY. Okay, now what would you do? We drew a square. Now what? No, you can keep doing this. What you would do is you would extrude vertically, right?
Yes.
So I'm going to draw your square right here. We extrude vertically, and then, but the problem is we get a box this time.
Yeah, how do you, that's the question I was
Okay, good question. How do we do it? What you would do next.
Do you angle the sides? Can you?
Yeah, so what we're going to do is we're going to cut away the sides. So on the XZ plane, which is right here, this is your XZ plane. Now you're going to draw a triangle, two triangles, and you're going to extrude cut. It's going to come in and it's going to cut away the edges. But look how many more steps that was, right? So now when you cut it away, now you can go, you get the same shape. Okay. Yeah, do you see the two red triangles? Yeah, so that's another way, but 3 steps versus 2 steps. So, good. You're waiting for me for?
I can wait for a break or anything.
Okay. Here, I'll just. If you want to check which of these are working, because I don't know, one of them is broken. So yeah, feel free to take a look. You know how those work, right? Yeah. Okay. All right. Good. I charged all the batteries, but I'm not sure if I charged all the controllers and goggles. Number 3 is charged though. I don't know about 1 and 2. I also don't know if number 3 is the one that's working or not. Actually, number 3 is working. But if you can check the other ones too, because I should label them. Anyways, okay, good. Any questions? All right, let's move on to someone's object. Let me see. Oh,
Here.
that one we'll get to. Actually, let me do this one. This one's good. Okay, we already talked about the cone, but I'm gonna bring it up anyways. Okay, here is a cone. Take a look at this cone. It's not just a simple cone. You see, it has like a little plug portion, because that way you can plug it in here and it sticks. If it didn't have that, it would just be like sitting on the top and it would fall off as soon as I tip it. Okay, so I'm gonna draw it again here. X, Y, Z. Here is the 3D object, and it has a little plug like this, okay? All right, you see the plug is circular. Okay, how do we draw this?
You draw a triangle.
Draw a triangle on what plane?
YZ.
YZ, okay. So you're talking this plane right here.
Yeah.
Okay, I'm gonna face the YZ toward us. Okay, and then you draw a triangle.
Yeah.
Like this.
And is there a way to, and can you just shape the bottom to be a circle around?
I don't know. What do you want to do?
Can we?
Walk me through it. Walk me through it. How do you want to do this?
No, I'm asking. Can you not take that and then shape the bottom to be a circle?
Right now, this is just a 2D shape. We don't even have a 3D object yet.
Oh,
So
so-
I just drew on the ZY plane. I just drew your shape.
Oh,
Oh, good. That's actually what we need to do. You see that? Christmas, half of a Christmas tree.
well, can you make it extrudable way? Can you draw that?
Explain what you mean by that.
Like, can you draw it the way we been talking about extrude way, where you take a triangle, extrude it?
So if you take this triangle and extrude it, you're going to end up getting something that looks like this.
So that's the only way you can do it.
Not the only way, but it's the most practical way
Okay.
to revolve it. It would make the most sense to revolve this thing because you see the problem with extrude? It's just going to linearly give it thickness
Yeah.
to your existing shape.
There's no way to extrude it this way.
Yes, but you're starting from a point.
That's true.
Yeah, it's not a defined shape. I guess you can draw like a super tiny circle and then you can
Yeah,
extrude.
that's
But that's lofting again because
Okay.
when you lofting is basically connecting two different shapes of, or it could be two different sizes. That's lofting.
I learned how to 3D model lofting.
Oh, okay.
That's
But
what I-
lofting is a little bit like more advanced later on, so we can do that later. But I'm just showing you the most basic stuff because this two methods, revolve and extrude, is like the basis for drawing almost everything here. Like with exceptions of like more organic shapes that I mentioned last time, like your seat, that's like an organic shape. Even something like that, even something like that, you can basically extrude, but then you would taper the corners and stuff like that. That's like mostly blocky still, right? Okay, so yes, this is what you would do. You would draw like this. Oops. You would draw like this. And specifically, you need to close it off. Remember, we cannot have an open profile. The program will yell at you. It cannot extrude an open profile. You need to close it off. So we close it off, okay? This can be drawn on either the XZ plane or the YZ plane because it is a cylindrical part. XZ plane or YZ plane looks the same. It doesn't matter which one you're dealing with. Okay, on other things it does matter, especially like non-symmetrical parts. One side's going to be longer than the other, right? If I look at this thing, this face is thinner than this face, so it does matter which one you're doing. But on a cylindrical part, it's the same no matter how I look at it from the side. So we'll just do YZ for the example. The red is our axis of rotation. Now we're going to rotate around like this. We're going to end up getting a Christmas tree, just like that. You see that? Okay. Except this is let me draw it in 3D. You're going to end up getting something that looks like that. Okay. Just like what we have here. Okay. This is a solid piece. So there you go. All right. You got that? Do you guys,
So,
Yeah, that makes
Yes.
because we're talking 3D printing,
Yes.
and I'm new, I apologize, but it's closed off. It's hollow on the inside, right?
This is not hollow. Okay. This is, for our purposes, this is not hollow on the inside.
Okay.
Because look, I mean, I guess we'll make the assumption it isn't because I can't see the inside. Yeah. Technically speaking, this is a 3D printing thing. This is not hollow. It's a bunch of like hexagons, or it's light because you feel it. There's air pockets in there.
Okay.
But for our modeling purposes, it's solid.
I just wanted
Yeah.
to-
The cone was, the example of the cone was not, it was hollow, I guess. If this had an opening you could see down, then that would be like an ice cream cone. Yeah.
There's so many ways I don't know yet, but so like
Mhm.
you could start with your previous example of a cylinder, a bucket basically.
Yeah, so,
But
mhm.
if you build the bucket up from the bottom,
Yeah.
is that lofting?
No. I don't want to talk about lofting yet, and I haven't showed lofting either. I'm showing only I'm showing two methods, so I'll talk about the two methods. The first method is extrude. Do you get extrude?
Yes.
Take a shape, give it thickness. Then there's the negative extrude, which is like taking a shape and you're cutting it. You're removing material with it, okay? They're both the same concepts, except one is adding material, one's removing material. So that's extrude. We'll just dump that under the term extrude. The other one is revolve. You take a shape
illustration.
and then no, you spin it around an
yeah, yeah.
axis. Okay, you take a shape and you spin it around the axis.
That was where I was going with that shape of the circle on the bottom.
It creates a circle because anytime you spin something,
Yeah.
it's always going to carve out a circular profile. Like that's just the definition of spinning. Just like you have a propeller on your drone. If it's just one propeller, but then you spin it, it ends up sweeping out a circle shape, right? So you're always going to have a circular profile. It doesn't always have to be a circle, like a. It's always going to have some
But
circle.
you can
like-
do that if you're drawing like a box.
Right, and then you have to extrude.
Yeah.
That's why you do extrude. Yeah. Circular things is like you can use like circular you can use for revolve you use to create circular parts, and then if you're creating something boxy like what we did here, this is not circular.
Yeah,
You
so
can't use the revolve. Yeah. Yes.
I'm sorry, what's the term for the opposite of extruding or
Yeah.
extruding away?
Depends on the software, but you can call it a cut,
Oh, okay.
or they just call it extrude cut as well.
Okay.
Yeah.
Then how
So-
would you do it if, like on the tripod mount? If,
Tripod mount. Yes.
Like, you know how it has a hole?
Oh, this?
Yeah, how would you draw that part?
So this is an extrude cut. You
Okay.
would draw the slot and then you cut away all the material. Try to relate to like real life. How would you make this thing? Yeah, like okay, maybe the way you would make it is you take a block and you shave off the corners like I showed here.
Yeah.
Right? That's what you'll probably do. So that's
Yeah.
not necessarily the most like accurate representation, but if you were to make this slot, what would you do?
Get a box.
You would
Get a
take like a drill and you would just like drill out the slot, right? So that's basically like you just create your drill like draws out the contour. Yeah, so you would draw this keyhole shape and then you just cut away the materials. When you extrude, you can either add material or you can remove material. Okay, so same with revolve. We can also draw a circle for the inside and we can revolve cut. You can also do that. So you can revolve create material like what we did here. We revolve create material, but then you can easily also draw a profile and revolve cut away material. Yeah. So, okay. Does everyone understand how we drew this thing? Okay, let's draw this thing. This thing is a little bit. It would have been simple if there wasn't these things, but this is gonna add a little bit more complications. So
Oh, there's slots?
yeah, so let me. Okay, so this device looks like this, but there are these little pegs sticking out of it, and you can't see on the back end. I could do dash lines, but I'm just gonna keep it blank. All right. Okay, at any point, you could see two of the pegs, or maybe sometimes three, right? So I just drew two for the time being. How would you draw this thing? Do you guys all? Do you want to see a little closer? Yeah. Is it good?
I think number 2 is the one that could
dead?
be broken and has a lot of hot glue on it, and it seems like.
Oh, the
there's
hot
something-
glue is because sometimes the
The
wires
glue.
came out. It might be actually okay.
Yeah, but
Yeah. But yeah, feel free to like actually turn it on.
Ooh, I
You used it before, right?
yeah.
Yeah. Okay. While that's getting passed around,
Can you draw-
just start with the cylinder. That's what I'm gonna say. Just start with the
Can
cylinder.
you guys draw a circle on the XY
Okay.
axis and then extrude it?
Yep. That works here. So in this case, you can either do a revolve, or you can do a extrude.
And then draw another circle inside.
Okay, so you're going to extrude this. I'm going to introduce a new thing that will save you a step. Previously, we talked about just creating a circle, extruding it, creating another slightly smaller circle, and then cutting it, right? Well, why don't, because this is a tube, and it's going to be the same circle profile throughout the entire length, why don't we just create a concentric circle like this? And then extrude that. Okay, that would save you that additional cut step. That again only works because in this case we have a tube. If you were to cut this at any point, it would be the same thing that you see here throughout the entire thing. In the case of my previous example with the cup, it's not the same. When you cut it mid part, you see this, but then when you cut to the bottom, you see a blank circle. So that's why this couldn't have worked in the other example. But in our case, it's literally a tube all the way through. So by drawing this ring, we can now save ourselves that extra step. Do you guys see why we do the ring?
Yeah.
We could have still done the other way, which is draw a circle, extrude it, and then draw another circle and
We do
cut
a
it.
ring because
You could do that.
It's open on the bottom.
Yeah, but because it's a ring throughout the entire thing, we can also just draw a ring to begin with and extrude it. That would save you steps. I'm just introducing these like little efficiency steps here. If you think ahead, you look at your object and you think ahead. I'm like, oh, like yes, I could do this method, which is draw bigger shape, cut away, or I could just draw a ring and extrude a ring. Think of this as just a series of rings stacked up on each other, right? That's literally what this thing is. Yeah. Okay. Yeah, sounds good. Okay. Next, what do we do? Because we have these little pegs. What do we do now?
And you draw a square and then extrude it out.
Yeah. So once again, we're actually going to go back on the YZ plane. Okay. We're going to go back on the YZ plane. Or sorry, XY plane. So this is what we have existing, right? We already have this thing. This is now looking at it from the top. We have this thing. But then what we're going to do, I'm going to add it in red. We're going to add these little pegs. You see that? And then we're going to extrude it, but only partially.
Yeah.
Just extrude it as much as you want to. So up to, okay, so then this is what you'll end up getting. You'll end up getting something that looks like this now. Here's our little rectangle. And here's our little rectangle. Here's our little rectangle, like that. So before, if I can find something, okay. All right, this is not exactly the same length, but before the first step, this is all we created. Simple tube. Then we added our red pegs. Okay, you see we added our little pegs. And now we gave it thickness, but only up to a certain point. And now we have our thing here, our rocket body. Okay, you see that? So this is one method. We only use extrude. We only use the extrude method. I probably would have just done this way, but how would we do this if we were doing a revolve method? How would you draw this thing if you're doing a revolve method? From the beginning. Let's just say a simple thing like this. How would you do it from a revolve method? Not down the middle. If you put a shaft through this thing like this, it would look like that, right? You see that? Like this thing can rotate around the shaft like this. Okay. And then whenever you want to try to determine the shape that you want to draw on a revolve, you have to cut this in half and just look at the top half. What do you see if you were to cut this in half and just look at the top half? Can't see it. Not quite. Not quite.
You can get the rivets on the side?
No, that would be a two-step process. I'm just showing you like how do you approach this with the revolve. If we cut this thing, if we cut this in half this way, because it has to go through the axis revolve. You see, this is my pencil is the axis. So if we were to cut it,
You get a U shape.
yeah, it would look like a half pipe like this, right? It would look like this. Do you see that?
Yeah.
Do you guys see that? We cut it. Okay, here's our axis of rotation. And then I only want to look at the top half because I'm going to take whatever top half right here and I'm going to revolve that. So what is the face that is exposed on the top half? It's just this thing right here. So literally, if I draw something like this, here, I'll draw it vertically. If I draw something like this, maybe it'll make more sense once we get on the computers. If I draw something like this, a stick, and then I revolve around this. This is my stick profile, you see that? I revolve around it, what do you get? You get a tube, exactly. You get this tube. So this orange thing I drew, this is the orange thing right here. This is this thing right here. I just took that and I go like that. Yeah. But then you would still have to do the same thing here. You would still have to do an extrude to get the, because yeah, this is not something you like rotate around. This is only at specific points. If it was a sleeve, like this is kind of like, I guess the opposite of a sleeve, but let's imagine if this is a sleeve, then yeah, you can create a little protruding part like this, and then it would create that sleeve. You see that? But we don't want this completely to be around. We only want it at increments, so that's why this would first create the tube, and then after that you would still go do the extrude. So we jump between the two methods, like incrementally, step by step. The goal is to try to do it in as few steps as possible, but you know, the goal is to get it right also. So if it took you a little longer, that's okay too. But that comes with experience. You'll start seeing things and you're like, oh, I can draw this way, I can draw that way. There's multiple ways to approach this. Who had a question? Oh, yes.
If you could scroll down so I could see that lower method,
Mm-hmm.
would you identify, I see the axis, but I get confused what plane is, what plane
Oh.
am I looking at there? What's the X and Y?
Okay. Let me
If we look at the other way, I understand, but what is,
yeah, let me rotate this. This is probably better if I drew it like this way. Okay.
okay,
Because I'm trying to keep consistent with the rest of them. I drew it the other way.
that's fine, I'm just,
But this would be, well, good question. What plane would it be? X is not a plane. A plane is defined by two axes. The Y, the XZ. Yeah, you see how it's like, it's flat. Like if we had the cylinder and the knife we took to cut the thing, okay, the knife we cut to cut the thing was like this. That knife is aligned with the XZ plane. Do you see that? Okay. All right. Let's.
I'm good.
You're good. Okay. I know some of you guys have other objects, so we can. Do you want me to go over those, or do you guys want to just give it a shot on the computers now?
Let's give it a shot.
You know what? Let me do one more object. This one's a little bit more unique. I want you guys to walk me through. Okay. This is actually not as hard as it looks. But. All right. Here we are. A little spatula. I'm gonna rotate it around the different views, just so you can see what it looks like. Okay. Does everyone get an idea of what this thing is? And now I'll pass it around. I'll just look at it one more time before I pass it around. You already seen it. Yeah. All right. Think about it. How do we approach this?
It looks like a spatula. What is its true purpose in this room?
For scraping things off of the 3D printer plate. So when you print things on the 3D printer, it's gonna like stick to the plate, and you have to like, just like getting an egg off the pan, you have to like scrape it up. So that's what it's for, which you will experience soon. Okay. Walk me through ideas. How do we draw this thing? There's gonna be multiple ways to draw it. And it's going to take multiple steps, right? There's no way we can draw it in like 2 steps like we did with this. It's not as simple as that. We're going to draw it also, even though this is made of 2 different materials, metal and like a plastic handle, we're going to draw it as one continuous part, okay, just for the purposes of this exercise. In reality, those are 2 separate parts, drawn as 2 separate objects, made separately. But for our purposes, let's just draw it as one continuous part. How would you approach that?
As I start at the handle,
Okay, how do you draw the handle?
extrude a rectangle.
Extrude a rectangle, okay. There's multiple faces on this. So give me a description. Which face of this are you trying to draw first? And on what plane?
Probably on like Y.
Maybe it's easier if I first place this on the I'll just first place this on my drawing. That way we have something to reference, okay? Here's our little spatula. You see that? It's not the best, but I think you get the idea, right? Here's our little spatula. Okay, now it's in line with our axes. Now we can start talking. Okay, what surface do you want to draw? What plane do we want to draw it on? YX, okay, YX. I'm going to draw your YX right here. And what are we drawing on the YX?
Rectangle.
Which rectangle? Because I have a rectangle here, I have one here, I have one there.
The handle rectangle.
A, B, or C?
Oh.
Right? These are all rectangles.
Oh,
Which surface you want to draw it on?
C, you wanna draw this, don't you wanna draw
Okay,
C?
we can draw C. So we're drawing C on XY. I concur. It is on XY plane. Okay, so I'm going to draw it like, I'm just going to make it a rectangle even though this has, you know what?
It's kind of round.
Let's draw it like the shape it is.
Or
This
you
is
draw
kind of how it is, all right? It's like a coffin shape.
oval.
Okay.
I thought it would be an oval. for some reason.
No, look at it. Look at
Oh,
the
that's
shape.
true.
It's not an oval.
Yeah.
Yeah. We're talking the handle now, right? Yeah, we're talking the handle.
Yeah.
Okay. So we're drawing surface C. This is the shape I have. And then what?
Extrude,
Extrude, okay.
but you have to extrude
So
downward.
Interesting. So this, if this was placed on the XY plane, this would actually look like this. You guys see it? Here, let me play. It's actually not even touching. It's not even touching the surface. What is touching the surface?
The bottom portion.
The metal
The screw part, yeah.
So we can draw. We're actually going to draw on the surface. Think of it as a shadow. We drew on the surface, but we're not going to extrude from the surface because there's a gap here. I'll introduce this new concept, but you guys see the problem, the dilemma right now.
Yeah.
Yeah. How do you extrude from this when it's not even here to begin with? It starts like this, and then it goes up a little bit. Okay.
Well,
So
do you extrude up?
you do extrude up, but you have to do what we call offset. So I'm going to draw this coffin shape that we just talked about. This is on our XY plane again. Oops. This is on our darn it. This is on our XY plane, but this is our shadow. What we're going to do is, just like when you extrude, you do it to a certain distance. You can tell it, hey, I want to offset the shape, and I want to actually start it in the air at this point. So now, even though we drew our shape on the XY plane, which is our surface, it doesn't actually start creating material until it's like an inch up. And then we offset, and then we extrude this thing. Okay, now we extrude this green, new offset shape. Okay? Do you see that? It's a floating in air now. Does everyone understand the offset? You see why we're doing this? Is because it's not even touching the ground. Okay. So now you have this handle. Okay, we use surface C. That probably makes the most sense because given that it's not a straight rectangle, if you're to use surface A, you see what the dilemma is? You can extrude it, but then it gets fatter and then it gets thinner again.
Yeah.
So you would have to it actually wouldn't
What would
work.
happen if you use
You would have to do a lofting method, which is too complicated for this.
What would happen if you use B?
B, Okay, if you use B, what happened is you would have get a straight rectangle, but then later you have to look up and then you have to do the cut like we did here with the triangles. You have to do a cut. So 2 steps. Surface C is the most straightforward because you draw the organic shape and you just extrude it once. You don't have to do something else to it. Yeah, A and B require additional processing. So you see why choosing the surface is important. Okay, now what? We still have our metal scoopy part. How do you want to draw this?
And then when you want to draw a rectangle onto the handle.
Okay, let's go. Let me redraw this thing. Okay. Ugh.
Or would you draw? Or would you draw?
Okay, I'm gonna point out to the surfaces again. We have C, we have B, and then A. I'm gonna come from this way. It's basically the same, but the opposite direction.
C.
Okay, you want to draw C. Okay, so you're gonna draw this, like this face, right? Okay, and how do you want to do that?
Draw an oval.
It's well, let's just say a rounded rectangle, right?
Yeah.
Rounded rectangle. On what plane?
Would it be the YZ?
Is it on the YZ?
Or is it the X?
Is
No.
this on the YZ?
Oh no, XY.
It's on the XY, yeah.
Yeah.
So we draw. Okay, now what? So I'm just gonna draw my rounded rectangle. Okay, like that.
And then you draw a neck
Where? On the same drawing?
on the same part of the XY.
Here? Like this?
On the bottom part.
Oh, okay, on the bottom part? Like this?
And then could you cut out, do a cut on the line?
Oh, okay, yeah, sure. We can do a cut. Like that?
Yeah.
Okay. Okay. And then? And then what do you want to do?
I mean, you have to make it.
You have to offset.
Oh, yeah, offset it.
Hmm?
Offset
You
it.
have to offset the other, like the little tip of it.
Yeah, offset the neck.
Okay, but right now we're still in a 2D surface. You can only offset once you are in the... Okay, so here's the thing. We step into a 2D environment to draw your shape. You step out into the 3D environment. And then you can start doing like
Offsetting.
3D manipulation. Offset is a... Yeah, that's like...
So would you?
Well, extrusion is a 3D manipulation. Revolving is a 3D manipulation. You can't say I'm gonna... Actually, technically you can. But okay, we'll just say like you can revolve like within the 2D environment. But those are 2 different commands.
Would you extrude?
Extrude, okay. So you want to extrude?
Yeah.
Okay, so...
If you extrude it, wouldn't it be fat? Wouldn't it get fat?
Yeah, it would. I mean,
Yeah.
there is a certain thickness to this, but it's like very
Yeah,
minimal.
yeah. Extrude it and then offset it, the neck.
How do you offset the neck? It's one continuous shape. If you want to offset the neck specifically, you need to separate that from the rest of the drawing, or you need to draw it separately. Yeah. Yeah. When you do something to a shape, it does it to the entire shape.
So what you're telling me, you would wanna.
I would have drawn the neck separately, basically, is what I'm
So
saying.
you know how I drew.
I wouldn't have drawn it in.
You know.
Because look, it's not continuous flat with the rest of it. So how do you tell this computer software, I only want you to do the neck, is you draw the neck separate to begin
So
with.
you know the square I drew?
Huh?
The square I drew for the neck?
Yeah.
So do I not cut it, and I would extrude it first and then offset it and then cut it, the line? Wouldn't that be an option? That option?
I'm not sure I follow what you mean.
So you know how I cut the neck?
How do you cut the neck?
No,
Because
not cut the neck, but you know how I cut the line to make it one big neck?
yes.
Take the neck part, extrude it, and then offset it, and then cut the line.
Yeah.
Is
So
it too complicated?
It's too complicated.
That's what,
Okay, there's an alternative approach I would
Is it?
take.
That's what I'm
Yeah.
asking.
You can save yourself here, but I'll come back to this one. There's an easier, in my opinion, there's a different approach I would take. What would anyone have any ideas? Because you see what he's talking about. He's talking about I have to create this thing, then I have to separate out the neck part, and then you have to like you can extrude this, but then you have to like make another cut and stuff like that. Yeah.
You would the neck and then put them together?
Yes. That's one way. Yeah, exactly. So let's say we just make the rounded.
I don't follow. I'm so confused.
Okay, here. I'm going to show you. So let's just say we make the rounded square. I'm going to close this off though this time. Okay. We make this.
Uh-huh.
You extrude it. Okay, now we have this little
Yeah.
thing. And then the neck, we draw as a separate item. Let me move this up. We draw as a separate line item, okay? I'm going to make this a little smaller. Okay. Let's say the neck looks like literally a rectangle, okay?
And then you extrude it and then you offset it.
Yeah, but the problem with extrusion is that it works great if everything is extruding to the same height. But you look at this thing, it's slanted.
Yeah. That's what.
So if you're going to extrude this neck, what I would do is not draw it on the XY plane, but rather I would draw it from the B direction, which is the YZ. You see that? I would have drawn it like this. I would have drawn it like this, the YZ plane. Ah, shoot. Okay, let me just redraw that square. You see? And then you would extrude this thing, and now you create that thing. You see that?
That makes sense.
Yeah. Because look, that's a consistent,
Yeah.
it's a consistent like thickness. Whereas this, it's like, it is a consistent thickness, but it like comes in and out of the page for you. Yeah. Do you guys see that's like we had to change the direction. So this is coming from view C. This is also coming from C. This is coming from C. And now this is coming from B, view B. And then you assemble them together. You just place them together.
And you cut.
If you place them in the right spot when on the drawing, they will just all come together.
Okay.
Yeah. There's actually an even easier way I would do it. Let me show you. The first part, the handle, I concur. How we do it right now, that's great.
Okay.
But there's actually one way you can do the other that I would prefer. And the reason I would prefer this is because I also think about how is this manufactured? How do you think this metal piece is manufactured? It's one continuous thing.
Stamp?
It's a stamp, exactly. What they do is they take a sheet metal
Oh yeah.
and then they have a stamper. It actually stamps out this specific shape,
Yeah.
but it's not flat, right? Then they bend the metal. They
Yeah.
put it in a press and it bends the
Bend
metal.
machine.
Okay, and then there you go. You have your thing like this. Okay, so I think about how do they actually like create this thing, and then I will.
Well, you didn't do the pouring method? That you showed
No,
me?
this wouldn't be practical.
Okay.
It comes down to economics.
Okay.
It doesn't make sense to do casting for
Yeah,
something
that
like
will-
this.
yeah,
Yeah. Plus, not to mention like the metal you get in the end wouldn't. Usually, it's not going to be like this flexible. Like the
A
steel,
little bit hard.
it's going to be like more brittle and more like it's going to be more stiff. Yeah. Casting, you have to use specific metals for. Yeah. So there's also
That's true.
there's all types of consideration. So here's how I would draw the scoop part. I would actually do it just from view B, okay, that angle, okay.
So how do you leave it the way we drew it?
No, this is how I would draw it.
No, I'm talking the handle part.
Yeah, the handle is great.
Okay.
The handle is done right. Yeah. Here's how I would draw this piece. I would draw it like this. Do you guys see that? Okay.
Uh-huh.
Okay, which is what? It is the ZY. Okay, then I take that piece, I extrude it. It's gonna look like a chair, all right? This is, right now, this neck is as thick as the rest of the body. Do you guys see that?
Mm-hmm.
Okay, now what I do is I go back into the same plane. No, actually it's a different plane. This time I'm going from view A, or is it C? What is it? C. I'm going from view C. This time I'm going to draw, this. And what you're going to do is I'm going to overlay this thing over here. It's going to overlay like that. Okay? Let me draw it like this. It's actually going to overlay like this. And then I'm going to say cut everything outside of the shape. And when you cut, it doesn't matter the thickness, it will just cut everything in its path. So even though we're on different levels, it's going to just like, it's just going to cut everything that goes between it and infinity.
So it was a step, basically.
It's like an opposite, yeah, it's like a stamp.
Okay,
Exactly.
that makes sense.
So that's what I would do, yeah. And then the cool thing about doing something like that is later, you want to create a different shape. All you do is you modify that green drawing, and now you have a new shape.
Now
If
I
you wanted to
understand.
change your shape here, this is not as flexible. You would literally have to go in, and you would have to like change the, you would change the other one. Yeah, so
So after you cut it on the outside, and then you extrude it.
it's already extruded.
Oh, you
This
cut-
time we're just, when I say we're doing like a outside, you can either cut whatever's inside the paddle, or you can cut anything that's outside the paddle. So in this case, I'm cutting things outside the paddle. Okay. And then you'll end up getting this thing. Oops, that's way too thin. You'll end up getting, dang it. To draw an organic 3D shape.
It's
Or,
hard.
yeah, it's kind of hard on an angle. All right.
It's like a paddle.
I want to show those methods just to get your juices flowing. Think about like how you would draw these devices. I know I didn't draw everyone's, but now you can start to imagine how you would draw these different things, right? You start thinking about it.
Kind of.
Yes.
Okay, so
Kind of. Just.
Kind of. We'll go through. Yes.
going back to the manufacturer and being practical to stamp it out, different materials, et cetera, but the handle, the coffin shape.
Yeah.
So, because we know it's two different materials, you would actually make a.
Oh yes. Technically you would.
But what plane would, and I'm just trying to
okay.
visualize, is that on, it's on the angle B, right?
So that slot would be right here.
Yes.
So it would be from B. You would go to B. You would cut that slot and you would extrude cut, and it will cut everything in its path.
And B.
So it'll just
is
clear it
the
right through.
XZ plane, no.
The B is the YZ plane.
YZ's looking straight down.
You see Y? Huh?
Oh, you're right, oh, I see. C is looking straight down.
C is looking straight down, which is the XY.
I'm good now, thank you.
You're good? All right. Any other questions? All right. We're going to take a break and we'll head over. So how about at 4 o'clock we'll resume back at the other room? Okay, the room next door. All right. Yeah, maybe you want to get your computer set up if you have time right now. Yeah.
Yes.
Because everyone else is set up. I'm just going to create a simple rectangle. Yeah, go ahead and just follow along with this. Okay. I'm starting off with a sketch. Okay, sketch is how you do 2D. Okay, we see we have our 3 different surfaces, the oranges. We have the, this is the XY. The Y is not shown here. Here, let me rotate this so we can see the way I drew it in class. Okay, you see right here? The green is the Y, the red is the X, and the blue is the Z. So this plane right here that I have highlighted, that is your XY plane. We're going to start there, XY. So just click on the one, yeah, hover over your mouse until it's XY plane. You should see top. You see, this should say top. And then you should see the red and green lines. Okay, so now we're looking at the XY plane. I'm going to just create a simple rectangle right here. You start at 0, 0, which is the, the test dummy symbol. Let me just put 25 by 50. Okay, I'm just going to do 25 by 50. Okay, right now, because of the dimensions I put on there, I have fully constrained or defined this dimension. What I mean by that is try to grab this corner. This corner doesn't move. Let me just draw another random rectangle right here. Okay.
I am behind a little bit with constraint, I don't have measurement to the side.
So okay, let me undo this. Okay,
I have my
are you
rectangle.
here? Are you in the XY plane?
Yes. Yes, I am. I just, maybe controlled. I am in the XY plane, like you said, and I draw,
Do you go to rectangle tool? You see the rectangle tool?
yes,
Click on it.
I did that.
Okay,
I need to probably start over. I did what you said, it's a 25 by 25 square. I just need to find a way to start a new one somehow.
Okay, so then just the dilemma is that if you just draw a shape, it's going to appear like, it's good, but you can easily bump it, it can move, it can change in shape if you don't constrain and dimension it. So if I tell you, put this box on a table, you do. Everyone's going to put it in a different spot until I tell you, put this box 2 inches from the or the x-axis and 3 inches from the y-axis at perpendicular angle. Then, with those specific directions, now everyone should put it in the exact same spot. All right, we need our shapes to be in the exact same spot. We don't want to just leave it to ambiguity, okay? So here's where we can start off. Let me just create a new drawing. All right, I'm just gonna discard everything. Okay, here, if you're at this page, let me just go back one more. Oh my goodness. Okay, you go to home. Are you guys here? Home. Then you go to new, right here. Let me see, how do I show the mouse? Okay, right here. New. Everyone here? Press new. It gives you this screen. Okay, remember our axes in the corner? We have X, Y, and Z. I'm going to create a sketch. We start with 2D sketch, create a shape, then you turn it into a 3D object. Okay, start with sketch. For the purposes of what we're doing right now, we're only going to deal with sketch. So 2D environment, all right? There's your 3 planes to choose from. We're going to choose the Y, X plane, which is bounded by the green and the red line. This one right here. You see the green and the red line? That is our XY plane. When you click on it, you should see the cube has now turned to say top. It's facing you. If it doesn't, then click on top. And if it's sideways like this, you see how the top is now sideways? Click on the arrows to keep rotating it until it's top. Is everyone here? Who's not here?
When I click on my top screen, it's blank. When I click on my,
I'm going to go to rectangle tool, which is conveniently in the shape of a rectangle. All right. It should say 2-point rectangle. That's just the default. All right, you don't need to worry about that for now. Just click on it. And the reason it says 2-point because you draw 2 points to define the rectangle. 1 point and then the diagonal opposite point, okay? So for now, I just want you to draw a rectangle. Don't put in the number. You see how the numbers show up? Don't worry about that. Just click anywhere random like this, okay? All right, click anywhere random. And then you should get this rectangle. Everyone got the rectangle? I'm seeing some no's. Everyone's rectangle is going to be different, all right? And this is the whole point, because we haven't put any dimensions or constraints to it. There is 2 differences. Do you guys know the difference between a constraint and a dimension?
no.
Any guesses? What is William doing now? He's trying to measure. Well, that was the idea. When you're measuring something, you're putting a dimension. That's giving actual numbers to the length, the size of it, okay? That's a dimension. A constraint is more of geometric properties. Is something parallel? Is something perpendicular? Is something coincident? Collinear? These are all constraints. You guys get that? Like, there's no number associated with it. It's a different way to align your piece, but you don't put a number. I just say these boxes are parallel, but it doesn't tell you like that's mine. It doesn't tell you the distance, but it tells you it's not going to be like this. When I say it's parallel, you know it's going to be like this. Now I say it's perpendicular, you know it's going to be like this. Okay, so that's a constraint here. But we have also dimensions. So let's look about the dimension first. Dimension is I want to give this a specific size. Let's say I want to make this box. Okay, well first you need a ruler. So I have a ruler. Let's just do that. In order for you to do a constraint, or in order to, yeah, well I have a different one because the one that is not working. Right now, by the way, we are working in metric, so this is millimeters. I'm going to tell you the width of this box is 280 millimeters. Okay, so how do you put that in? You go here. Do you see that there's this shape right here that has it's a sketch dimension. It's like a goalpost, like a football goalpost, okay? It has two vertical lines with the arrow in between. Okay, what you do is you hover over the edge that you want to give a length. Okay, so look at this thing. I measure this, so this is what we want to hover over. I'm going to hover over this thing. You see that? And you click on it, and you see a number pops up, some random number, because I just randomly drew this thing. Okay, then you want to click to set the position of that dimension, and then it's going to give you the option to enter a number. So we're going to put, what did I say, 260, 280? What did I say again? 280. You're going to say 280. You don't have to say millimeters because we're already working in metric, so you just put the number 280. And you press enter. When I press enter, the box is going to shift so that it becomes 280. Look at that. It shifted. Okay, it became 280 now. All right. Try that. Everyone got that? Let's do the same thing for the height. The height now is 105. So I'm going to go here. I'm still on the same tool, sketch dimensions. Now you have your two options. We can either do this left edge or we can do the right edge. In this case, it doesn't matter because it's a rectangle. So both left and right is the same. So let's just choose one of them. You're going to first click, and then you want to set it somewhere. I'm just going to set it right here. 105 is what I said. Put in 105 and press enter. And now everyone should get the same size box. Your box may not be in the same position as mine, but at least it's the same size. So I should be able to go around right now and see. Do you notice that this is blue? So blue tells you that it is under constraint. It's ambiguous. It can still move. What does it mean by that? Well, I try to grab any feature of this, and look, the height can change because the height has not been defined. Let me try to change the width. I'm going to grab this. I can't change the width. Why? Because I already constrained it, or I already defined it to 208. It has to be 280. Okay? But I haven't defined the height, and therefore it's movable, and that's why one of the edges is blue. Once you define the height, like I'm going to do right here, 105, now it turns black. The whole thing is black. That means your shape is fully defined. Now, try to grab your shape. Some of your shapes, if it's not anchored or constrained, it can still move. But the actual shape itself should not change in size anymore. Is that the case for some of you? Let me show you what it looks like when things are not constrained. Let me see here. Sorry. All right. That's actually why yours is probably not black yet, because it's still movable. Even though the shape is not going to change,
Right.
it's not placed in a specific location yet. Okay, so what we need to do is we need to do what's called a constraint. So you see right here, we have a list of constraints right here. Let's make sure we all understand the differences though. Okay, so we have horizontal vertical. Horizontal vertical is as it tells you, it means that this line is going to be horizontal. We automatically create that with a rectangle. You see, you have this little thing here, this little icon here tells you that I'm going to make this horizontal. Because when you create a rectangle, it assumes you want a horizontal rectangle. If I delete this, look what happens. I can now, give me a sec. Okay, I have to also delete the other one because that's just the nature of rectangles. But now, dang it. Okay, let me. I have to first anchor it. Let me first anchor it, and then I can show you. Because right now, whenever I move this thing, oh, there it goes. You see, it's starting to shift. It starts to shift. It starts to shift. Okay, it's kind of random though. See, I can't really control how it shifts, and that's the whole point. I'm trying to show you why we need constraint. But you see that I deleted the horizontal, and now it kept 200 and 100, but only kept it for those two edges. So if I go here, and I put horizontal, vertical, boom. It fixed it, just like that. Let me undo that. You see, without the horizontal, it's just going to be free floating. With the horizontal, it became horizontal. Okay, so that's one constraint. The other constraint is called coincident. Coincident means 2 points are going to be aligned. And that's actually what we're going to do next. I want to put this rectangle, oops, I'm sorry. I want to put this rectangle corner right with this, okay? Now what you can do is you can hover over and it'll snap right onto it, and that's what I did the first time. But I want to show you like more manual way. So you click on the corner, and then you also shift, hold down shift, and click on this corner. So now both of them are blue dots. That means they've been selected. You press coincident. Boom. It makes both points the same location. Do you see that? It snapped right to that thing. Let me show one more time. I'm going to click this, press shift, click on the second point. Doesn't matter which one you click, okay? Then I'm going to click on coincident. Okay? Let me delete some of these. Okay, so now I deleted the horizontal and the verticals. Because it's coincident, that corner is not going to move. But I can keep moving the rest of this. Okay? So let me do another thing you can do. I can go here. Okay, look at this. I can go here and then press shift again. Also click here. Okay, I clicked on the two long lines. And now I'm going to make them parallel. You see now they're parallel? That's what the parallel symbol stands for. Two double lines. That's parallel.
Show me again where you found the parallel.
It's right here. Do you have constraints?
I see it now. I see it. Yeah.
Okay. In a rectangle, your corners need to be perpendicular with each other, right? Yeah? So I'm going to go here and press shift. Press and hold, I should say that. Press and hold shift and then click. Oops. Okay, the reason that messed up is because it was trying to do another parallel, so it made everything parallel, and thus it became a line. Okay, I'm going to do that one more time. Press shift, press and hold shift, and click on the edge. Okay, so now I have these two edges right here in the bold, and then I'm going to press perpendicular. It's going to make it perpendicular. So now this is a 90-degree angle. All right. If I make this perpendicular, now it returns back to a rectangle because basically two perpendicular opposite corners makes a rectangle. So you see what happened there? So those are various constraints you can use. You notice with the constraints you don't put in a number. You just you create a geometric relationship with each other. This is parallel to this. This is still parallel to this. This is still parallel. They're still parallel. Okay, so you don't always need to put numbers. I like to use geometric constraints. That's a lot cleaner. And sometimes that's the only way to really constrain something. If I draw a circle here, and if you want the circle to touch this line and not intersect, then we're going to do what's called a tangent. Do you guys remember from trigonometry? This might be a while for some of you. When something is tangent, that's when you have a curve that is just touching a line at one point. So it's like resting a ball on a table. The ball isn't hovering above the table. It's not going into the table. It's just resting theoretically on one point. But of course, you know, the ball can deform, the table can deform. So, but in theory, on a computer, it's just touching on one point. So tangent, I'm going to click on this, press and hold shift, click on your other line, and I'm going to press this thing, tangent. Look what happens to the circle. It touches that line. I can keep zooming in infinitely, and it should be theoretically one point. You see? I keep zooming in until the resolution of this thing. Okay, this is just a resolution problem. That's why there's a gap. But in theory, it is touching like that, okay? Now, I can roll my ball. See, I can't roll it yet because I haven't. I have to give it a size. When you try to move something that has multiple things unconstrained, like in this case, the size of it is constrained, the position of it is constrained. The computer doesn't know which one you want to move, so it just chooses one. In this case, so that's why you have to start constraining things. So now now that I constrain the size of it, I can start moving this, and it's gonna stay on the surface. You see that? It always stays on the surface because that's what the tangent does. The tangent always says, I'm going to stay touching that.
Will it go around the corner?
No, because I only said I want to be tangent to this corner. Here, let me do something. I'm going to put this. How do I get this flat again? How do I get this line flat again? Which of the constraints? Which of these constraints will allow me to get this line flat, horizontal? Literally in the name, I just said it. The horizontal constraint. Exactly. I'm going to go here. Let's get that horizontal again. Okay? Now, Beth asked, can this go around the corner? And the answer is no, because I only constrain it to this line, not this one. So what happens if I go off the edge of the rectangle? What do you think is going to happen?
It's gonna stop?
No, it's going to keep going. It's going to keep going.
Oh.
Because this is still imaginary, like the red line is like collinear with this. It's going to keep going. It can't go around that corner. Same with this. It's just going to keep going. So it is still in theory tangent to that line, even if the line ends, but the line, if it's extended, it would still be tangent. So, all right, go ahead and play with those. Play with the different constraints. There is another one that I don't want you to use because this is like a cheat. It's called fix and unfix. So basically, I put this lock there, and then it fix it, and it makes you think everything is nice and hunky-dory, but basically you just put glue on it, and you just fixed it in space now. That's not really like the only time you should do that is like for one part as the base of your assembly, and then everything can like work off of that. But you shouldn't fix things in space because everything needs to be a relationship with each other, right? I say I put this on top of this box, and this box is on top of this box, and this box is on top of the table, and the table is fixed to the ground. Only the table is fixed. I don't want you guys to fix other things in space, because otherwise it stays in space even if you like shrink the table. It's going to be like hovering in space. Yes, your question. So don't use that. Even though it's there, it's a cheat. Don't use that. Only for specific purposes. Mm-hmm.
In the top right?
We do that. I've been using specific tools, rectangle and circle, right? But probably the most useful tool is going to be this one. Okay, this is called the poly. Let me see what they call it. Oh, they just call it line tool. Sometimes it's called polyline tool. But this is like think of it as like a pen that is stuck on the paper and you can't lift off, but you can like draw it in different like shapes and
Any
stuff.
shape you want.
So this is more organic. Yeah, so I can draw a rectangle. Look, I could draw a rectangle. It's not going to be the most beautiful rectangle, but it's not a problem because I have my constraints. I can go here, horizontal, horizontal, vertical, vertical, and I made it a rectangle already, even if I didn't draw a rectangle. This is useful for things that we showed earlier in class. Remember the little Christmas tree thing we draw? This thing? Okay. I could do this. And I quickly drew that. Instead of creating a rectangle and then adding that to a triangle, you just draw all in one shape. So go ahead and play with that. What you can do is when you click on this and then you click and drag, you can even make a curve. Okay? And then I can continuously be making shapes even without lifting off and changing to different tools. There you go. I made this weird shape. You see that? Okay. Yeah. So that is the line tool. And to get out of it, because I call it like rubber banding, because it's like a rubber band, it's keep holding onto it. You just press escape key on the keyboard. Actually, the escape key is used for any time you want to get out a specific tool in general. Like let's say you are trying to horizontal, vertical constrain something, and it's like, I want to switch to a different tool. I mean, you can click on a different tool, or you just press escape, and it gets out of it. Yeah. So, all right. I mean, I don't know if this is the same for you guys because I'm using a Mac, but like I know at least the scroll wheel is in and out. That's zoom.
Yeah.
If you press and hold the scroll while you move around, what happens? Mine orbits. What does your do?
You pan with that one.
You pan, okay. So it's slightly different.
And the mouse.
And then if you press shift, mine also zooms in and out. But if I press like control, then I'm able to pan it. So basically it's a combination, I guess it depends on your computer. It's a combination of command. I mean, I call it command because it's on the Mac, but control or shift or just pressing and holding. It will do different things. So just
Press,
check it out.
pan, and then scroll to zoom in and out, and then shift to like change the angle that you view it.
Change the angle. Okay.
Yeah.
So press and hold will pan. Shift is going to change the angle, like orbit, like what I'm doing right now. Okay, that's orbit.
And then just scroll and zoom in and
What about control?
It doesn't look like it does anything.
It doesn't do anything. Okay, all right. Well, that covers it. Basically, there's three possibilities. You're zooming, you're orbiting, or you're panning. Another thing that's also useful is when you select. This is actually applicable across other platforms too. When you select something, you can either select it from the left going right or the right going left. And that will either select everything that's connected to it. Okay, so let me show you what I mean. If I go from left to right, you see right now, if I go left to right, it creates an orange box. You see how I only touched a portion of those lines for those two shapes? You see that? This line and this line, I only touched a portion. I didn't encompass the shape. I just touched a portion of that. When I let go, nothing happened. So that tool, when you go from left to right in the orange box, in order to select the thing, you have to completely encompass it. You see, now I completely encompass this shape, and now it selects it. On the other hand, when I go from right to left, it creates a yellow box. As soon as you touch any portion of it, it's going to select the entire thing. Okay? So if I touch like this, you see I touch both the triangle and that other weird shape, it selects both. So that could be useful. Okay? Sometimes you have multiple overlapping shapes and you only want to select this one thing. you're more likely to use the thing that is like going like this. So let's say I drew a triangle within this thing, right? You see that little triangle? Only the triangle is completely encompassed. The other thing is not. So it's only going to select the triangle. So that's where it's useful to use like left to right or right to left. There's actual terms for it, but I forgot what it's called. But okay, to delete.
Yeah. You just click on the line and just click delete.
Yeah, I mean there's also
Yeah.
there's different tools to do it. So let me create this organic shape here.
I mean, or if not, can you not use the trim tool?
There is a trim tool, yes. That's what I was going to
Trim
show.
tool?
Okay, so you see I created this organic
Yeah,
shape,
that works.
but let's say I have this other random lines inside that I don't want. Okay, what I'm going to do is you can do a trim tool, the one that has a scissor. Okay, and then you can just drag your mouse. You can either click on segments or I can drag my mouse and wherever it touches, it starts to delete.
So it's kind of like an eraser.
Yeah, it's like an eraser, exactly. Yeah. That's the trim tool.
Or the other way I did it was just click on
Your
the
other
line
way
and-
is also works. You just click on it, but it's a little, you have to click on in. Or you could do what I just showed you earlier. You draw a box around something. Okay? Let's say I only want to delete the stuff on the inside. Which side would I go? Right to left? The yellow box or the orange box? I only want to
Orange
delete,
box?
huh?
The orange box?
Yeah, the orange box. So you see right here, even though I touch the outer surface, it's only going to select the thing that's completely enclosed, and then I press delete. That's probably going to be your easiest way. Instead of going to a trim tool, you just like encompass it. It depends on what you're trying to do. If you're trying to delete this one line, you have to do that. Yeah.
Would you show me how to do the tangent again?
The tangent. You mean like a circle to a line?
Yeah,
So first I'm going to create a circle.
that's what I didn't do.
Yep. You have to have a circle and then you have to have a straight line. That's the definition.
Okay,
So I have a circle, I have a straight line.
thank you.
I'm going to go to tangent tool. I'm going to click this and I'm going to click this and it makes a tangent. Just like that. Another thing you could do, and this was just like what I showed earlier in the other classroom, you can do a concentric circle, which is a ring. So where's a circle, here's another circle, but they're not concentric. To make it concentric, you do this. What that means is you're putting both center points aligned. Both center points are coincident now. So I'm going to click on this, and then click on this, and now it becomes a ring, perfectly centered.
Did you hold shift when you?
There's two ways to do it. So let me show you what I did. So you can either first activate the tool like I did here, and then you don't have to press shift. You just click on one feature, click on the second. The other way is, let's say I didn't have a tool selected. You see right now none of these are selected. Then you have to do the shift. Shift is just telling you I'm selecting multiple things, and then later you go in here and you specify what command you want to do with it. So the order told me like I first selected objects, then I selected command, or you do a command and then you select the objects. When you do it the first way, where you just select objects, in order to select multiple objects, you need to press shift. Or the other way I just showed you, which is you just drag a box around it. There you go, multiple objects selected. That's another way. You can press shift and individually click the outline, or you can just encompass it in the selection box. So I did the same thing and I concentric it. Try it.
I will.
Okay. This handy device is called?
Caliper.
Yes, it's a caliper, okay? So this is a digital caliper, and it makes things a lot easier. You can switch between millimeters and inches, so just press the units right here. We're going to use millimeters because that is the unit of measurement in our drawing. And then, as I mentioned in the previous class, it's actually what we use primarily for drones, anyways. So, and as well as the rest of the world. So, good to get used to it. So, there's a couple of things we need to measure, and I'm gonna get a piece of paper at the same time. And maybe what I'll do is I'll just draw it here on the screen. That way we can keep track of it. Okay, so we're gonna draw our little Christmas tree, right? Or let's just draw the whole thing. I'm gonna draw the whole thing. When you draw these things, there's multiple dimensions and multiple. It's easier if you look at it from different views. Actually, this one you can completely encompass from just this view. But I'm also gonna look at it from the bottom. You see the bottom looks like this. Okay, so you see two circles. So I'm also gonna draw it like this. So this is bottom view, and this is like front view. Okay, so let's go ahead and let's measure this. So tell me something to measure. We need to make sure we measure. I teach the other AutoCAD class. So in our in our fusion drawing, okay. So what do we need to measure? Tell me something.
Base. We need to know the base. So
The base, the diameter. Okay. So I'm gonna open this up right here, and you're gonna keep opening up, and then I'm gonna close it up. And then there's this little like thumb wheel right here. You don't want to excessively push because then you're gonna get a smaller number than what you want. So what you want to do is you want to keep pushing until your thumb slips like this. Okay. That way you get a consistent pressure. Okay, what do we read?
33.12.
33.12. Actually, before we do that, I'm going to close this. You always want to make sure it's zeroed, okay? Otherwise, you're going to be off. Okay, so we're zeroed. If it's not zeroed, you press a 0. Okay, so it's 0 when it's closed. Let's just measure one more time for good measure. 33. Okay, 33.2. I'm going to say that. We have 2 decimal points. Let's use that, okay? 33.2. So this is, I'm going to draw it just like you see in our fusion with the little double-headed arrow. 30.2 millimeter. That's the same thing as right here. You see that? Let me draw this a little cleaner. Okay, so that's the same thing right here, the 33.2. When you draw this is a diameter. It's typically drawn with this symbol. It looks like a 0 with a line through it. That's a diameter symbol. You see that? Okay, so 33.2. Great. What else should we measure? Huh? What's that?
The notch.
The notch. What about the notch? How do you want to measure
You
them?
want to measure how tall the notches are?
Okay, yes. So there's multiple surfaces here. This is for measuring internal openings. Like if I had a hole, you can open this up. You see that? Here, let me show you. This is for internal openings. So you see right here, I go in here and I measure internal open. So that's what that is for. This, which we just used, is for measuring external surfaces. And then there's finally one more thing here, which is kind of for measuring pockets. It's this thing here at the bottom. You see it protrudes out as well as we move this. So I'm actually going to use that thing because this is hard to measure because it's just going to go into open space, right? And this is also the same thing. This is just going to go into open space. We don't really want that. But what I can do is I can rest this right along the edge, like so. And then I can open this up until it bottoms out. And now I read 5.21. Okay, I'm just going to say 5.2. 0.01 millimeters is really tiny. So I'm just kind of rounding this out because there is also dimensional inaccuracies. There's inaccuracies in this device, and also when you print this thing, there's like slight inaccuracies. So what you're going to find as we do things is you're going to measure exactly how you see it, but then when you print it out, it's like slightly bigger or smaller, and things aren't always going to fit perfectly. That's just reality. It's like, you're trying to take something that's perfect in the computer and make it a reality. So like you might have to make slight adjustments. So anyways, For our purposes, I kind of just rounded out that extra number. So 5.2, good. What else do we need to measure?
The top part?
What about it? Tell me, what are we measuring?
The length
The length, okay. What length?
from the top to,
The notch
the
or
notch.
to here?
yeah.
It's actually, okay, so here's a practical thing. Look at it right now. If I was to measure from to the notch, look what happens.
Oh, would you do from the top to the bottom and then minus the
Exactly.
Yeah,
That's more practical because here's the problem. You measure to the notch. Look, I'm at an angle.
Yeah,
That's
you can't
not
measure
good.
correctly.
You're not gonna get the actual height. You're just gonna get the height of the slope. You're gonna get the
Yeah.
length of the slope. So we need to measure to the bottom. Now we get the actual height. What do we see? Oh, let me do my thumb thing. Okay, it's slipping. Okay, 104.65. Okay, let me go back to here.
104.65.
See, this is why we have these
Well,
extension
would
lines.
you
You
do
see?
the minus it?
Well, I'm just reporting the numbers. We can do all those minuses and stuff later in the computer.
Oh, okay.
So right now, 104.65 millimeter. You see, this is why we have those little extension lines. Because if I just drew it like this, it's a little ambiguous. Okay, so you want to draw those extension lines right here, so it's clear what you're talking about. What else?
And then the width.
The outer width.
Yeah.
I agree. Yes. Okay, so let's just go here. And I'm just gonna try to get it like this. Okay. All right, good. What do we got? 37. 37.05. I'm just gonna say that. The numbers dance around a little bit because it's 37.05 millimeters. I'm sure their intention was probably 37.
And then would you
But-
want to do?
So I'm gonna just draw an arrow, and I'm just gonna say I'm gonna give it diameter symbol like that. Yes, William?
Would you want to do? Measure the width of the top part?
Width of the top part. We're going to assume it's a point. We're gonna assume it's a point.
Oh, okay.
So there is no like.
Well,
There's no width to it.
When you 3D print, wouldn't you want to know how?
You mean this? You mean this thing?
No. I'm thinking about the whole.
Oh, I'll show you. It doesn't matter because we're gonna draw. Yeah. We don't need to. We're gonna approximate. We're gonna assume this is a straight line. If this is not a straight line, then you would have to like do other measurements throughout.
okay.
But we're gonna assume this is a straight line, so there's no need to measure intermediate widths if that's what you mean.
Yeah.
Okay, so I think we captured it all. Is there anything that you think we're missing? We got the total height. We got the notch height. We got the inner and the outer circles.
Or would you want to do? We don't need. Oh, because we're gonna minus subtract.
Yeah.
Later.
Yeah, I think we got it.
Yeah.
We got it. Okay. So let's go ahead and draw this together then. Even if you don't have this thing, here, let me put this on the side. And then I will minimize this window so that we kind of see it. Okay. Even if you don't have this object, you can draw it on a piece of paper, hand it over to someone to draw. All right, this is nice. Okay, I'm gonna start new. Let's start a new. I'm gonna finish sketch. I'm gonna delete the sketch because that was like trash. All right. Start sketch. Okay. How do we want to draw this again? Do you remember?
Wait, you won't.
Remember this? Remember what we had here? The little Christmas tree, right? Okay, so let's draw that. Now what plane do we want to draw it on? Because this object is normally upright like this. So which plane do we want to draw it on?
XY? No.
No.
No. It will be the Y, the XZ.
There's two options. You can either draw it on this or you can draw it on this.
XZ.
It doesn't matter because it's like cylindrical. So I'm just going to choose XZ, okay? Just like this. It should see front view. You see front on the cube now?
Oh,
Okay. Now we're gonna use our line tool that I showed you previously. Oh, I want you to draw, imagine the Z, which is this green line right now. The Z is that dotted line that you see right here. It's the axis of revolution, okay? So yeah, so we want to draw, even though I didn't draw the axis of revolution, you want to draw it imagining it's there. So your thing, if it's set up correctly, it should do what's called snapping. Do you notice when you move your mouse and it just snaps right to the green line? You shouldn't have to like lay it exactly on. As soon as you get close, it snaps. You see how it's jumping around as I move? Is that happening on your guys' screen? That's a feature that's, I think, turned on by default. It's a good thing for us. So if not, we can use our constraint to still get it on that line. Don't worry.
I'm looking for where snapping tool is.
It's not a tool. It's just a feature that's turned on. When you move your mouse to the green line, does it snap to it? Does it seem to jump around? Does it seem to jump around from square to square on your grid lines?
So if you use a concentric.
Concentric only works with circles. There is no circle here.
It says two or more objects that so that they share
Yes.
a common line. Just
That's coincident. That's probably what you're talking about.
it's concentric. I'm hovering
Concentric is two or more arcs and circles with the same center point. That's what concentric is. You're talking collinear probably. Yeah. Constraints two or more objects on the same line. That's collinear.
The third,
We're not going to use those. Just use the ones that I mentioned previously. Which one?
fourth one?
Which one? Give it the name. What's the name? Horizontal, vertical, coincident.
Coincident, yeah, that one.
Which one?
Coincident.
Okay, what do you want to do with this one?
I'm trying to rotate it.
Right now we're not rotating it. We're still in the 2D environment. Remember, 2D, you don't do 3D actions. Rotation is a 3D.
What were you trying to do?
I'm trying to get this shape to look like this shape.
Oh, from where the funkiness.
Yes, you see how it's
Oh,
funky?
okay.
How do I straighten this thing up? Just using constraints right now. How do I straighten this thing up? The ones we have for us, I'm just going to tell you.
Is it equal?
No, okay, these are the only options that we're going to use, at least for this example. I only want you to use horizontal, vertical, coincident, parallel, and perpendicular. Just literally those four. Just one of those four. What do we start with?
Horizontal?
Horizontal, vertical. And what do you want to make horizontal and vertical?
Want to make the right hand.
This one?
Oh,
Okay, it's looking better. What else?
And then the bottom part?
Looking better. What else?
And then the side of the notch?
This?
Yeah.
Looking better. What else? This?
Yeah.
Okay, anything else?
And then,
when we do the
do we want to
measurements,
shrink it down?
Okay, no, I don't. Okay, so we're done with horizontal and vertical because obviously this one's not going to be either
Yeah.
one. So we're done. I'm going to press escape. Okay, looking good. Looking good. Now, this is not in the correct position. You see, I need to have this in line with that green, which is going to become our axis of revolution. So how do I get that over there? Which of the four constraints I talked about allow me to get over there?
Coincident. Coincident.
Okay, coincident. What do I do coincident?
And are you selected?
I selected the tool first this time, so we don't need to do shift. Okay, what do we do?
We take the two corners,
This one?
that corner,
Uh-huh.
and we pull to the center of the, yes.
Very good. Looks good.
You use both?
Well, you don't need a pull. You literally just click the 2 points. It will pull itself together. Okay, this general shape is there. Now we can start putting in actual numbers, right? Now we got the general shape. That's the first thing you got to do.
Oh.
All right, let's start putting in actual numbers. So here is the numbers that we're dealing with. All right. Now you notice I drew a full Christmas tree, but in this case we're doing a half Christmas tree. So some numbers need to be halved, some can be preserved. So maybe we'll start with the ones that are the same. The height is the same, right? That hasn't changed. So how do we want to dimension this? I'm going to go to modify, and not modify, I'm sorry. Create dimension. Right here. Mine is squashed, so it like disappeared, but
Is it the sketch dimension?
no, it should be create dimension. Yeah, sketch dimension, I'm sorry, you're right. Okay, so what do we want to sketch dimension? Vertical. We have two vertical dimensions. What do we got?
The slanted line?
I never dimensioned the slanted line.
Oh, no, the straight line.
Yeah, so from this point, you see the top point to this bottom point is going to be what? Says on the screen.
104.65.
Correct. Ooh, it just grew huge. Okay, all right. That's good because I probably drew it too small previously. That's why like the thing blew up. Okay, what else do we want to dimension? The bottom? What?
33.20.
Let's deal with the vertical ones for now. What else is vertical?
Oh, the notch.
The 5.2?
Yeah.
Okay, 5.2. Boom. All right, we're done with the verticals. Let's do the horizontals now. Now, because the horizontal, we're going to have all our dimensions because I only drew half of the Christmas tree. So, got to do a little math. Sorry. Okay, so let's do this width. This trunk was supposed to be what?
33.20.
Yep.
And then divide in half.
Uh-huh.
Half.
Well, the good thing is you can do math straight in here. So what I'm going to do is 33.2, and then you press divide by 2. You see that? I don't even have to think about it. It makes it too easy for you. 33.2 divided by 2.
Divide is
Slash.
slash.
And it would do it for you, which is 16.6, okay? It will do the math for you. Let's apply that same concept to get the outer width.
So you're going this way. How do you get to
Well,
not vertical, horizontal?
Hmm?
Not the vertical way.
Hmm?
You know how you measured the bottom piece?
Yeah.
How did you do it to be vertical?
What do you mean vertical? This?
Yeah. No, not vertical, I mean horizontal. The bottom part.
Is yours not horizontal?
How did you get it to vertical?
It should be horizontal by default. Again, this trunk of the Christmas tree is going to be half of what I drew here, right? Because you see this thing right here, I drew the full width, 33.2, but I only drew half of a width here. Okay, if that's too much math, you can do the math directly in the sketch dimension. You just click on the dimension. What would have been 33.2, you just add divided by 2, like this. And you press enter. And it did the math, it says 16.6 for you. Let's do the same thing over here. Once again, I'm going to do sketch dimension from this corner to this edge. What is it normally supposed to be? Do you guys read it? 37.05, and now we're going to divide by 2. Boom. Just like this. You should get a really tall, spiky... This is starting to look like our thing, right? You see that? Now it's starting to look right. Huh?
You did 37 point, what was it?
37.05 divided by 2. 05. 37.05.
Yeah.
Divided by 2. Divided by 2. There you go. No. Your dimensions are wrong.
Huh?
The location is wrong. Look, you measured this.
Yeah.
I measured from here to here. which is the same as saying, okay, this full width, half of it is from this. So you need to actually put your measurement from here to here, not from here to here.
So go from.
You should not see any blue lines. And if you just try to grab a corner and try to move this thing, it shouldn't move. All right, that's a good sign. Okay, and then everyone has theirs in the corner, right? I mean, they have their corner in the origin point. Okay, now we can finally exit the sketch. So just press the finish sketch. We're gonna go to the revolve. You see the revolve tool right here? Now we're in 3D tools. Now we're in 3D environment. So now we can do 3D things like revolving, okay? So I'm gonna press the revolve. The shape is already selected. All right, if it's not selected, then you select it. And then we have to select an axis. You see that? It gives you two options. Select the profile, which we did. Select the axis. The axis I'm gonna select to be, you can open up this, you see this folder that says origin? You see that? We're gonna select the Z because the Z is what we wanna rotate around. Okay, once you select the Z,
You won't do anything.
now you get your shape.
I'm clicking on it, it's not doing anything.
Okay, so we got our dimensions. The one math we have to do is we got the total width with 2 nubs, and then we also got the outer diameter. In order to find the protrusion of one nub, we have to do the total width, which is 41.42, minus 37.55, all of that divided by 2. Do you guys see where I get that? Okay. So the outer thing, so basically we're taking this 41.42, we minus this inner circle right here, we're left with the difference between the two, which ends up being this edge plus this edge. And then you want to divide by 2 because we're only going to draw one of the nubs. And then, yeah, so that's where we did 41.42, 41.42 minus 37.55 divided by 2. 1.935. 1.935 millimeters. All right. Okay, so that means this actual protrusion right here is 1.935 millimeters. Okay. At this point, you might have already drawn it. If not, we're going to create a sketch. We're going to draw on the YZ plane 2 concentric circles. I'm just going to draw 2 circles off in space, and I'm going to show you if you didn't make it like on the origin. I'm going to first make them coincident. Concentric, okay? 2 circles are concentric. So I'm going to click on that, click one circle, click the next circle. They are now concentric, meaning they share the same center point. The other constraint I'm going to do is coincident. I'm going to take this shared center point, I'm going to take the origin, and I made it coincident. Finally, we are going to do dimensions. What is our dimensions again? You can see it over here. We have the outer is 37.55. Oh, gotta zoom in now. The inner is 33.3. Okay. Does everyone have something that looks something like this so far? Proportionally speaking, okay? I'm going to finish sketch. Okay. I'm going to finish sketch, and now we're going to extrude. We're going to give it thickness. How much thickness? we have a height of what again? We have a height of right here 137. Okay, I'll just put 137. Boom. And now I created my tube. Okay.
You're selecting that,